dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. So welcome back from Forest. We want to continue our lesson. Still we are in chapter 5, what we call organic chemistry. So before I start this new lesson, I want to remind you last class we came across what we call alkenes. Say definition of alkenes, some properties of alkenes, reactions of alkenes, uses of alkenes. So we were there, use of alkenes. For today, we want to start what we call IUPAC names for alkenes with substitutions. What does mean IUPAC names? When I say IUPAC names is International Union Pure and Applied Chemistry. So pure and applied chemistry. So those guys, it's like a union. So they are responsible for whole chemistry. So for today, we are using their rules. Their rules for what? Naming of alkenes, what we call nomenclature of alkenes. So how to name an alkene molecule? How to name an alkene molecule? So we are using this. What about here with substituents? For example, if I say alkenes, which means they contain only hydrocarbons. It is like a chain, only chain. When I say substituent, some of the hydrogens are substituted by what? Another species, like alkyls. So it's not, for example, if we compare alkenes and alkenes with substituents, it's not the same. For example, if we have alkenes, it is like what we call say methane, ethane, propane, butane, bentane, hexane, heptane. These are the alkenes. But if you have 2-methylpropane, it's not an alkene. It is an alkene. We can say it's an alkane, but it's not a pure alkene. It is alkene with substituent. Because one of the hydrogens is substituted by what we call methyl group. So we want to name an alkene molecule with what? Substituents. When I say substituents, are branched path. For example, we can remove hydrogen from the alkane and we can put alkyl group. So these are called what? Alkene with substituents. So we want to name, how to name alkene with substituents. So these are the we can summarize around what we call, we can summarize around only three steps. We can put around 5, say 6, whatever, but we can summarize around 3. So number 1, so write alkene name. First, you have to write the alkene name. So that's step 1. We have to write the alkene name of the longest chain of the carbon, which means you can choose the longest straight chain. Choose the longest chain. We can say like this. We can put like this. Choose longest chain. So you can choose the longest chain. What does mean longest chain? The chain. When I say chain, it contains. It has highest number of carbons. So for example, here I want to start this one. Okay, consider here. We have alkane. So our substituent is So what are the substituents? We already mentioned that one. Substituents are there, or say any species that can replace hydrogen in an alkane is called a substituent. So in our substituents in alkanes are always what? Alkyl. Say number 1, alkyl. So alkyls are like what we call, say this one, CH3. What about this one, C2H5? What about this one, C3H7? What about this one, C4H9? These are our substituents. So we are using this. Say number 1, it contains single carbon, 2 carbons, 3 carbons, 4 carbons. So number 1 I can call what? It came from methane, but at this time it is a methyl. So we're supposed to use what? Methyl group. What about this one? It is acyl group. Here is what? Propyl group. It came from propane. Propyl group. It came from butane, say butyl group. Butyl group. So these are our substituents. The other possible substituent in an alkene is our what? Halogens. So we are familiar halogen is, say fluorine, say chlorine, bromine, okay, iodine, statin, it will not react together, it will not react with alkenes directly. So we can choose these three, for example, these three. So we can add chlorine, we can substitute hydrogen, we can remove hydrogen, and we can put here chlorine. So when you put that chlorine, or what you form is called halogen alkenes. So we will explain that one later, we shall see. But how can I mention chlorine? For example, if chlorine is attached, one of the carbon is in an alkene, you have to mention the carbon itself. For example, it is attached to carbon number 4, so you have to say 4-chloro instead of saying what? 4-chlorine. 4-chlorine. So we can name this one. We can say what? Say chloro. What about this one? Bromo. What about this one? Iodo. We can mention like this one with the help of what? Carbon number. Carbon number. Which carbon number is this iodine attached? For example, if it is carbon 3, you're supposed to say what? 3 iodo. 2 bromo. You can mention like this. You can mention like this. What about alkyl groups? Alkyl groups, they behave in a similar way with these halogens. So you have to mention, for example, if it is attached to carbon number 2, you can mention itself, say methyl. Which carbon is attached to this methyl group? Say carbon number 5, so you have to mention 5-methyl, 3-ethyl, say 6-propyl, whatever. So this is our substituents in an alkenes. So here you have what? So rule number 1 says what? Write alkane name of the longest chain of a carbon atoms. So at this time, the carbon numbers are what? Longest chain is here. For example, if I count 1, 2, 3, it is too short. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That's the longest chain. So first, when you choose the longest chain, so longest chain is what? It is 6. So what is the name of 6? It is hexane. It's hexane. So rule number 1, you don't want to mention substituents. So rule number 2, number carbon atoms starting from the end near substituent. For example, if there is no substituents, you can start carbon number 1 any corner. It's up to you. You can start from what? Right, left. You can start from top to bottom, wherever. But if it contains what we call substituents, say methyl group, bromo methyl group, you can start carbon number 1 at the corner near the side chain, what we call substituent branched. So I can start here, for example, 1. So 1, 2. So I can reach 2. What about here? If I start here, 1, 2, 3. Okay, I want to explain this one. What about if I start carbon number 1, this corner, say 1, 2, 3, so I can reach the branch, the substituent, the side chain, carbon number 3. What about if I start here? I can reach what? 1, 2, 1, 2. So you have two options. You can reach these 2, and you can reach these 3. These 3. So which number is smaller? 2. So you can choose 2. The other thing, the other option you can do is what? You can add these numbers. 1 plus 2. 1 plus 2, it is 3. You can add 1, 2, 3. Say 6. So choose the lowest summation. So which summation is lower? Say this is 6 and this is what? 3. 3 is the lower. So you can choose what? 3. So shall I start from left to right or right to left? So which side is correct? We can start what? From left to right. So that's the correct one. Okay, so you can number. So now this rule number 2 says what? Number carbon atoms is starting from the end near the substituent, near the side chain. So we can start from here because of the lowest summation. Lastly, so when you finish these 2 rules, so rule number 3 says what? Give the location and name of each substituent. You have to name each substituent and location. When I say location, means carbon number 1. So I say which carbon is attached to this substituent. Again, I say alphabetic order. We can put alphabetic order as prefix to the name of the main chain. So we give first we name this parent name. We give the numbers. Again, so how can I put? I can say 4 bromo. What does mean 4 bromo? Say carbon number 4 is attached bromo. It's attached bromo. So I have used what we call alphabetic order. So bromo should be first. So carbon number 4 is attached what we call bromo. Carbon number 2 and 4. Carbon number 2 and 4 is attached what? Carbon number 2 and 4. So where is carbon number 2 and 4? This is carbon number 2. You see? This is carbon number 2. Okay. So this is carbon. So this is carbon number 2. And this is carbon number 4. So carbon number 2 and carbon number 4 is attached what? Methyl group. So I can say 2,4 di what? Dimethyl group is attached. So I can say 4 bromo, say haven, 2,4 dimethyl hexane. 2,4 dimethyl hexane. So this is how to name an alkane. So we shall continue. Okay. What about here? 1, 2, 3, 4, 5. So at this time I don't want to write the hydrogen list. So they say this contains single bonds between all atoms. So I want to mention the substituents. Here I have what we call C2H3. What about here? CH3. What about here? CH3. Again, I can put here another carbon. So another carbon, CH3. So first step, we have to choose the longest chain. If you start here from left, 1, 2, 3, 4, 5. Well, here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So that's the longest chain. So you can write what we call heptane. You can write like this one, heptane. So this is the parent name. What about the side chains? Before the side chain is, can you number? Yes. If I start here, the number from left to right or right to left, I can reach this side chain, this substituent, carbon number 3. What about this one? 1, 2, 3. I can reach same principle. It's 3. So they are equal distance. At this time, you can use what we call alphabetic order. So which comes first? You see, this is called ethyl group. This is called what? Ethyl group. Say this is called what? Methyl group. So you can consider this one. It is ME. So which comes first? So E should be first. So you can start from left to right. Say 1, 2, 3, 4, 5, 6, 7. We have this one. Okay, my student is, as usual, we can start E. So I can put here 3 ethyl. Say 3 ethyl hyphen 3 ethyl. So I can, okay. Okay, 3 ethyl, comma. Do I have another side chain? Yes, methyl. Methyl is attached to carbon number 5. So I can say 5 methyl. 5 methyl. So carbon number 3 is attached to ethyl group. Carbon number 5 is attached to what we call methyl group. Then say haven. You have the chain. So it was 7. So 7 is called what? Heptane. 7 is called what? Heptane. So because of time, I'm supposed to stop here. We shall continue this lesson. Thank you very much.